Okay, so welcome to the contributed paper session. So we are going to have 4 papers in this session, and I will chair the first 2 papers, and Marco will take over for the last 2 papers. So the first paper is by Tommaso Battistini, Nicolò Isaia, Andrea Sterbini, Marco Temperini, and the title is DrPython Web, a tool to help teaching well-written Python programs. And the speaker is Andrea Sterbini.
Hello, good afternoon. This is a joint work with 2 students, Tommaso Battistini and Nicolò Isaia, that have built the software with Marco Temperini, and we work at the Sapienza University of Rome, Italy. The motivation for this work starts from the fact that we teach programming fundamentals in Python since many years. And the students are a lot, so they have to complete at least 4 homeworks to be admitted for their exam. And so we get 500 submission in average for each homework, because we are running 4 parallel courses, and we use the same homeworks over all the 4 parallel courses. In the evaluation of the homeworks, we use unit testing for assessing the correctness of the solutions, but we give also some small bonus to students that implement faster solutions or less intricate solutions, so that they modularize their code by writing the smaller functions. One other thing that we do in our system is that we ask the student to participate to a formative peer assessment phase where they can suggest to each other how to improve their respective algorithms. Obviously, we don't show them their code, but we show them just the algorithm descriptions that they submit together with their code. And from these suggestions, they can improve their programs and resubmit them during this formative peer assessment phase. What we have noticed is that the code that is submitted sometimes, not every time, but sometimes is rather ugly, not commented, very difficult to understand. And so we would like to check for the programming style and award some points to well-written programs. So we have looked around for tools to analyze the submitted programs and extract features that can help us understand if the programs are well-written. And we know that there are tools to extract quality assessment measures from code, like the McCabe cyclomatic complexity and the Halstead's matrix. We already use the McCabe cyclomatic complexity that we call intricacy, and so we justify to the students that they have to write smaller functions by saying that we want to have less intricate programs. We have looked also for linters and stylistic checkers, but these are mainly focused on the program formatting. So the spacing, the camel case of how do you write the case of your identifiers and so on. And this is not what we are looking at. And there are in literature also other types of features that are extracted from programs, but mainly they are easily measurable features, like the size of the identifiers, the number of characters of the variable names or function names, and the quantity of comments in the code. So what about the actual readability and understandability of code? So this is what we are focusing our interest. We think that code should be easy and to understand and maintain, because more than half of the effort in managing a software project goes to maintenance in the industry. And also a focus on writing well-commented and understandable code would help also students to in the analysis phase of the exercises that we give them. These are not easy exercises. They are somewhat intricate, and they ask them to really think to what they are doing, understand how to present the data and how to manage the data, and maybe find efficient algorithms if they want to get the efficiency rewards. So we already have the algorithm description submitted and the code, and we can compute the time for execution and the complexity, the Cape cyclomatic complexity of the code. And we want to add a programming style assessment to push the students to write more elegant code. But the thing that comes to mind as a question is, first, is elegant code tied to better results in learning and in the course? This is something that we will discover after the next course when we will apply this system. And also another thing is that students will change their understanding of the language during the course. So they start maybe 1/3 of the students normally has no previous abilities about programming. They don't know nothing about programming, and so especially for these students that doesn't know anything about programming, we know that they will change their understanding of programming during the course. So for each one of those homeworks that are spaced 2 weeks from one to the other, we will have difference. So the same student will know differently how to program and what is the readability of a program. So the interesting question will be to look at how the readability changes both in the code submitted, so the judgments of the students, how do they judge the code, and how are the judgment changing because of the changing perception of the students in the course. So this is something that we will be happy to explore next year. But what do we mean actually with the code readability and let's say elegant code? We want the code to be easy to understand. It should convey the ideas the algorithm is based on, the choices that the student had to implement the code, the implementation. They have to understand easily what are the data structures and what are the data that are inside the variables and the attributes of objects, and what is the flow of the data. So the meaning of the project, of the program, should be easily understandable. So this means that we need to do a more linguistic code analysis than a structural code analysis like it's done in other quality assurance tools, where the meaning of the program is normally not analyzed. So the two most important things we think that convey the meaning are the identifiers that are used for variables, functions, and the name of classes that describe what is computed and what are the actions that are done in the computation. And the documentation that describes instead, then the algorithm describes the choices made to explain. They try to explain why one has made some specific code implementation. So this is a snapshot of where we are with this project. We have started with a library, building a library to extract features from programs. We call it DrPython. And this is the work of Tommaso Battistini. And then we have built a web interface that allows us to build a rubric that could help the teacher to define how to award points to specific features extracted from programs. And in the next year, we are going to run the courses with the students. And we will both reward the submissions with the rubric that we are going to define. And most importantly, we will collect the readability assessment from students on their peers' code. And then we will have the data to analyze, that we will check for both improvement in code style and grades, and to see how the rubrics weights can be learned from the actual data collected. We have looked around for other projects, and we have to say that the name of our project, DrPython, is heavily influenced by Dr. Scratch. That is a tool that has been implemented to analyze programs made by kids with a Scratch visual language, the one with blocks that you stick with each other. And the projects made by kids are analyzed with respect to some features, like the complexity of the if conditions, presence of concurrency in the code that you can do in Scratch. What is the complexity of the data structure used, if there is that code, and other features. And in some way, the students can be judged, or at least the project can be judged and can be assigned a skill level that depends on how complex the code is. And so the student, the kid, can get a skill certificate. And there are other works on stylistic analysis of programs, for example, on App Inventor, or there is this ACES project, PhD project, where there is a focus on style features for Python programs. And again, here, there is no specific attention to linguistic. It seems to be that there is no focus on linguistic features. And this recent project on feature extraction from Python programs, again, for recognizing the style of programs. And again, here, the features that are extracted are measures of size of identifiers and dimension of comments and so on. So here are the four groups of features we extract: language constructs, code smells, code quality assessment measures, and the linguistic features that are the main novelty of our approach. Why do we extract also language constructs? The teacher teach some of these specific constructs from the language, and could want to push students to use more advanced constructs instead than simpler but more, let's say, less elegant, less Python-esque solutions to the same algorithm. We use the Red Baron, Red Baron library that allows us to query the abstract data, the abstract syntax tree of the program, and extract these features. The syntax for extracting features is rather easy, and this allows us also to extend the set of features that we want to extract. A second set of features we extract is called code smells. This is a terminology that is used in the industry for a set of indicators of low quality analysis. So there are some cases. So if your class has too many methods and or other smells, so they are called code smells because they suggest that something in the project stinks. And this can be, again, extracted with Red Baron by writing some slightly more complex code. The normal quality assessment matrix that we are using are the McCabe psychomatic complexity I talked already about. and we can extract also the Halstead effort that is tied to the number of operators and the number of identifiers, and so the vocabulary size of the program. So it measures the complexity of the program as a set of operators and words. And we have also the normal source line of code and the logical line of code and other common metrics. Just to give you an idea of what we have in front of us, we have more or less 10,000 exercises submitted in the last 4 years. And so we have started with just a very small subset of 100, 200 examples. We have divided, we have chosen 50 good, well understandable programs, 50 that are medium understandable, and 50 very unreadable programs. And just to show you, for example, the Halstead effort of these programs, we see that there is a higher Halstead effort on the badly written programs, and this is reasonable because students tend to write bigger functions instead than splitting the code in smaller functions. So this means that the function has a higher number of operators and identifiers. So obviously, this data that I'm showing you is just to have a sense of what we have in front of us, but it's not conclusive because it's more or less 1% of an analysis of 1% of the data we have available. So let's look at the linguistic part. So we are not able yet to understand in the proper way the meaning of what is written in the text. And so we start with a simplistic approach. We extract keywords from the text. And we use to do that, we use the SPACY library, that is a natural language processing library used to analyze free text. And a Pi8 automatic term extraction is the acronym here. Pi8 library that is used to select the most important keywords of a piece of text. With these two, we extract keywords from 4 sources. The problem definition written by the teacher to explain to the students what they have to do for the exercise, and this is used as the reference keywords. Then the algorithm description submitted by the student, the documentation strings and comments embedded in the code submitted, and the identifiers used for function names, class names, method names, arguments, variables, and so on. And then we look at the similarity between the keywords extracted from the student submission and with respect to the keywords extracted from the problem definition that are used as a reference. And then with these, for example, on the identifiers, we try to split the identifiers in 3 groups. Good identifiers are the ones that have a high similarity with at least one of the reference keywords from the teacher. Medium identifier have medium similarity with some of the keywords of the teacher. And the bad identifiers are the one that have almost no similarity, so they have a similarity lower than 40%. Okay, it's obvious that these 2 thresholds, 90% and 40%, are not based on data, on actual data now, because we don't have yet data that suggest us what is the proper threshold to use, but we start with that. And we will learn the right threshold levels when we will have the readability data from the students next year. One idea that we have is that in the meantime, we could analyze the feature distributions by running the DrPython library over the source code of the most important Python libraries. This could give us the feature distributions for very good written programs, because The libraries should be easy to understand. The documentation is inside the libraries. The choice of the name of attributes and function and identifiers should be understandable. And so this is exactly what would be the goal for a very good written program. And again, to show you a sense, I have a small sense of what we hope to get. I show you again this small subset of programs analyzed, and we see that in this small subset there is a behavior that is nice. We see that the bad identifiers, even if they are defined in that poorly way that I showed you, there are a lot present inside very not understandable programs, and good identifiers are almost not present in that case. While in good programs and in medium programs, we have, for example, in good programs, the number of identifiers that are bad are a lot lower, and we have a lot more reasonably good identifiers and very good identifiers. So we see a behavior that is reasonable with respect to what we would like. For example, here is another feature, the average number of comment lines in the code. We see that good programs are more commented than medium, and bad programs are has almost no comments. Okay, so one important thing of the project is that we will collect a readability assessment, and so this would be helpful to define, to come to a definition of code readability that is based on data, but also to analyze how the perception of the code readability changes with time during the course. And what would be interesting is to see if from the perception of a student or from the actual readability of the code that he submitted, we can predict his performances either on the exercises or on the final exam. And this would be helpful to tell them how they are going, or in the worst case, at least to get some suggestion about what would be the set of dropout students, so that we can plan some remedial activities for them. The DrPython web interface is what is used, can be used to define, to let the teacher define a rubric, where to each range of feature values we can associate the number of points that the student collects. So the student will submit their programs to be assessed with respect to the rubric defined by the teacher, and the results will be shown in a leaderboard, so that the students can compare their work with each other and see what are the features values, and maybe work on improving their program style to get a higher value for their features. So we want the teacher to be able to define a specific rubric, because let's say, for example, it's not suppose that you don't have yet explained how to use exceptions in a Python program, then it's not reasonable that you give an award to students that are using that, because this would be unfair to the students that are still learning, while the more experienced one will get points. Maybe you could discourage the other students. So we want to be able to build a rubric that can be personalized to the level of the single exercise. This is a couple of snapshots from the interface. On the right side, we see that for a homework one, we have 3 different rules that associate a weight 1.5 points, 1 point or half point to the half-set effort, if depending on the range the student will get from the program. So whenever this teacher has to define a rubric, he can define separate ranges with separate number of points. In this way, we are free to build shapes of function mapping the ranges of feature to the points at will. Okay, so for example, here we have 3 rules for the half-set effort and 2 for the cyclomatic complexity and 1 for good identifiers. And here is instead a small screenshot of what is used to select a feature, and here below insert what is the weight associated to that feature and the range where this rule is valid. And from that, when we apply the rubric to programs, every student gets a column. We show only the columns related to the rubrics selected features, and there is one column showing the value of the feature extracted from the program, and the column showing the weights, the points that the student gets from that. So for example, in good identifiers, we have that this student here used 80% of good identifiers, so he gets 1.2 points, while the other students are using a lower number of good identifiers, and this means that they don't get any point on this. So this could push the student to improve the names of the variables used or the names of the functions used in their program and resubmit the code. Okay, thanks for hearing me. This is all what we are doing. Other questions?
Thank you, Andrea. So are there questions? Okay, while hoping to get some questions, I want to ask you, the description of the problem given by the teacher is in Italian.
Yes, but we can analyze this also in English, because the SPACY library and the P8 library can extract keywords also from other languages. So we can extract it also in French or in German, whatever language.
Or in English, I guess, because in the most natural way to put comment.
Yeah, and we have also students that takes the same course in English, so we have to adapt. We have to use the code both for the English course with English descriptions and for the Italian course with the same exact problems, but with description that are in Italian. And we use the WordNet semantic connectors in Italian or in English, depending on what is the actual code, the language used by the student. Let's say the language used by the course more than the student.
So anybody wants to ask a question? Otherwise I can go on with another question. So are you planning also to have a kind of cheating detector? So trying to
we have that. Yes. What I do is I first let's say I have first normalized the code in the sense that I remove all the text that is not related to code. Let's say documentation, docstrings, comments, and so on. And then I get only the text, the actual code implemented by the student, and this is sorted in order of size, just to have an order that could put beside each other two functions that are copied from one student to another one. And then I use JPlug or similarity tester to one of these two systems to check for similarity. And when I this allows me to detect pairs of programs that have from 50% up of structure of code that is paragonal, that is similar. And then we are for teachers, so we look at these selected pairs and we judge we judge by reading the pairs of programs. And if there is at least 2 teachers that thinks that these pairs of students have a too similar pair of programs, then we just zero that pair of programs. The student can always remediate a nulled exercise, because we publish also some recovery exercises that they can do if their exercises are, let's say, late. So if the students are working students and they cannot work on the program for the exercise number 2, they can have the recovery version of the same exercise and do it when they can. And in the case of cheating, again, they can do that.
Okay, I don't see any questions, so thank you very much again, Andrea. So we move on to the next, maybe if you stop sharing so Jonathan can share your, okay. Yeah. Okay, so Jonathan, you can share your slides.
Okay. Hopefully you can all see the screen.
Okay, yep.
Okay.
So the next presentation is by Jonathan Bowen. It's a joint work with Peter Breuer. The title is Formal Methods, Communities of Practice, a survey of personal experience. Please.
Right, thank you very much, Antonio, and welcome to everyone. This talk, when I got the reviews back, it said, what's the research methodology? So essentially this talk is just based on personal experience of building formal methods communities over my career, for I guess almost, well, nearly 40 years now. So I hope that it'll help some of you if you're developing communities in your own areas. So a little bit of background, as you can see, it goes back to the 80s and 90s. So I've been involved in formal methods since about mid-80s, specifically with Z notation, building up the Z user group, starting early meetings and gradually developing into larger conferences, international conferences, etc. At that time in the 80s and 90s, I was also involved with Esprit projects a lot. So these themselves were little communities, some of which then went on to continue being communities for a long time. The Esprit Procos project on provably correct systems, it lasted for nearly a decade with different projects and a working group and so on. But then people have kept in touch, the communities continued, and we even had a get-together not so long ago in London of existing people who were there for the original project and new people who joined the community and the continuing work related to the project. And another Esprit project at the same time was the Redo project. This is where I actually first met my co-author, Peter Breuer. This was on software maintenance. We were looking at formal methods for software maintenance. So again, I've continued collaborating with Peter all that time as a result. Moving on to this century or millennia, I've also been involved with the formal aspects of computer science specialist group. So that's another community of people interested in formal methods, I guess more general than just Z, for instance. But specifically with Z, as I said, it started with a Z user meeting, then it joined with the B method and became a ZB conference. More recently, it's become the ABZ conference, including ASM and other formal methods. So that's the way a community can sort of meld with other communities and create new communities. And that continues till now. Obviously, it's been online recently, but there was a ABZ 2001 online this year, and it's going to continue in the future. Just a few specific examples. So FACS had workshops, so we've been interested in teaching formal methods education and so on. There have also been books on formal methods that bring different communities in formal methods together, because there's a lot of different types of formal method. And this book, for example, let people use their own formal method on a particular case study and compare with other formal methods. And this was another community based around Egon Borger, who's a leader in the ASM community. This was his celebration of his 60th birthday, again bringing together a lot of people interested in well, state-based methods in general, like ASM, Z, and so on. So I guess I've been involved with, as you can see, with various different formal methods communities through my career. And more recently, I guess I've looked more at interdisciplinary aspects of research. And so I've been doing research with sociologists, philosophers, and so on. And in the social sciences, there's this concept of a community of practice, which is a way of thinking about how communities develop that have got some particular aim. So this was originally conceived by Wenger, Etienne Wenger. This is an early book, is another early book. So there have been a lot of books on communities of practice and how to cultivate them and make them grow and so on. And the idea of the framework is to look at how a community develops with various stages. So I'll briefly go through some of those stages. So a community of practice is just a collection of people. It can be a community, it may be a local community, but now that we've got the internet, most communities that are doing research in computer science are distributed around the world, and the internet's a great way to bring together those communities of practice very easily. And obviously recently with the pandemic, that's been even more important. So these are the communities I've been mainly involved with, but I'll sort of elaborate a bit more how it fits in with other communities in formal methods. And I guess typically you're normally developing or contributing towards some sort of body of knowledge, and these can be formalized in formal methods. There's the SWIBOK, which is looking at software engineering in general, but that includes formal methods in particular. So here's what it looks like to somebody who comes along to all these different communities of practice. If you're in industry trying to look at these different formal methods communities, it can actually be pretty difficult to decide, everyone hunkers down on their own particular. I'm a Z person, there's ASM, I talk to the ASM people, but we all do have our own communities, and as an industrial person, it can be quite difficult to choose. So one thing I've been keen on is bringing together these communities and helping that poor person in the middle decide which community they should be involved with. So the different elements of a community of practice, you need a domain of knowledge. So in the case of formal methods, that's going to be around some particular formal methods like ASM, like the B method, like the Z notation, and so on. All separate communities to start with, but all with interrelated interests and so on. And you need to build up that community. So in computer science, you're going to have researchers, but you're going to have practitioners, you're going to need committees to organize things. We're here OpenCERT, that needed a committee to get it going. So you need these different people with different skills. Some people will have skills across some of these different areas, but you certainly need to cover all these different areas if you're going to develop the community. And the practice is the domain. So, the more general domain for formal methods is software engineering, but then formal methods itself is a subdomain of software engineering. So then there's these different stages of developing a community of practice. So when you start, well, there's going to be some, you need to start with some network of people who are interested in getting the community of practice going. So in the case of Z, for instance, which I know best, this came about because Jean-Raymond Abrial visited the programming research group in Oxford and managed to, well, came up with the idea of Z and showed it to other people at the programming research group. Other people liked it, so they started using this Z notation for formalizing software systems. And gradually more and more researchers at the PRG got interested, and it was formalized more with Mike Spivey writing a book on it, eventually a standard and so on. But you need that start somewhere to get the community going. Small scale to start, but hopefully it's going to expand. So in the case of Z again, then you need to start coalescing, and you need some sort of rhythm to a community. So certainly meetings are very good for that. And if you make it an annual meeting, then you know there's always going to be an annual meeting at least, and people can get together then and gradually build up the community. I mean, as it matures, it's going to get more enduring. So you need more formal meetings. So our first meetings were very informal. There was no proceedings for the first meeting. Then we just had a very informal document recording the next couple of meetings. Then we started having proceedings that was published by Springer for the Zoom meetings. Then it sort of combined with B and APZ and so on, continues with published proceedings. But you also need books. So Z's done quite well publishing books on Z and so on, and that helps promulgate around universities with teaching and so on. So continuing, well, you need some sort of stewardship. So, we had the Z user group for Z, so that was a formalized Z user group with a constitution and so on. And that meant there was and we had a bank account and all that sort of thing. So, we were independent to a certain extent with that, so we could decide what we wanted to do when we were organizing meetings and so on. We weren't tied to a particular university. And then that meant we could also collaborate with other communities around formal methods. So I've listed a few there. And of course, there are other organizations involved with formal methods. The most general one is Formal Methods Europe. So it gives you a chance to collaborate with other organizations as well. So, the community develops by having some sort of formal structure like that. But of course, all communities eventually end in some way. So a community can end at any point in these different stages that I've just shown you. So, if a community isn't successful, it will end before it really gets going. But Z, I think, got through these various stages. And normally, if you want a successful community, it's going to morph into some other communities. Certainly with Z, it really morphed into the community around the B method and the event B, which are more tools-based. So that was always one of the problems with Z, not very good tools. So nowadays, people expect tools for formal methods, and doing Z tools, although there are some, they're not so easy to use, whereas B has some quite industrial strength tools now. So you need to cultivate your community of practice. So you've got to let it evolve naturally. I mean, you can't control everything, so people will write papers anyway, but you can try and help people do that and so on. So you can create opportunities for doing that, allowing discussion. So Z, the internet was there. We had a mailing list, electronic mailing list. We had an FTP website originally, FTP site, which became a website, and so on. And then the meetings were obviously most important, which developed to be more and more formal. Eventually, the APZ meeting or conference. You have to allow different levels of participation. So there's always going to be a core of people sort of organizing. So I guess I was in that core for Z in particular. But then there are going to be people sort of outside that who are maybe, you're going to have a committee probably involved with helping organization. Then you might, if you've got a meeting or conference, you're going to have people who write papers. You're going to have people who just attend the conference. They're going to be further and further out in this circle of participation. Then there can be outsiders. You can see there looking in and seeing, do I want to use formal methods or Z or whatever? So you need to allow all these different levels and encourage them. And you're hoping that people will sort of move in to the middle levels gradually, but you still, there's going to be always more people on the outer levels. So in the case of Z, you know, you have researchers actually developing Z and producing a standard and so on. You have students hopefully learning Z. Certainly we had a lot of people learning Z at one point, especially in the UK. Probably about half the universities had some sort of Z teaching. You need to get industry involved. So, you know, you need to bring them in, hopefully, to come and attend your meetings and conferences and so on. Within industry, and I have worked in industry on big Z projects and so on, because one of the nice things as an academic, I think, is to always, especially in computer science, it's good to try and go out into industry and do some work there when you can. So particularly with Z, for instance, you can use Z for testing. So it's very important that you teach people to read Z, which is a lot easier than writing Z. So you can train up a lot of people to read Z and use that for testing and also for implementing the system from the Z specification. But then you do need a few Z specifiers. So this is a bit like compilers. You know, you need people to know how to compile, but you don't need many people writing compilers. So actually writing Z is a lot smaller number of people involved. On the project I was on, it's probably 150 people on the project, maybe 10 involved with actually writing any Z. The largest team was the testers, you know, over 50, and that was actually larger than implementers. So you can see the sort of scale on these different levels. Then you need some people who at least appreciate Z. So the managers don't have to be able to read or write Z, but they need to know it's a useful approach, and they need to have a buy-in on that to know, yes, we do need to use Z. Formal methods, especially good for safety critical and security critical systems. So the managers need to understand that. They may think, well, this is taking a long time to produce any software. Well, it can be sometimes, but you're going to have more correct software, which is very important if you're in the safety critical, security critical areas. So you need to develop different facilities. Some of them are public, some may be more private. So workshops became conferences. You need information on Z and ASM and so on. So again, nowadays, websites and so on, even getting your information on Wikipedia, wherever, you need to get the information out there. You need books. So Z probably had about 15 textbooks overall written on Z, which is quite good for formal methods. But then I remember doing a comparison with Java, and there are probably over 1,000 books on Java. So that gives you an idea of scale. Of formal methods is still fairly niche, but important in areas like safety and security critical areas. And you need courses, tutorials. So there still are industrial courses for Z and so on if people are using Z for projects. You need to look at the value of the your community of practice. You need to make it try and make it exciting. So that's where conferences are important. You know, make sure you've got a good community spirit around the conferences, and keep that regular rhythm going with, well, maybe it's newsletters, maybe it's conferences, maybe etc. etc. But you need to ensure there's something regular happening. With the FACS group, for instance, we have a regular newsletter, we have regular evening seminars and so on. If you don't have those things going on, and the community will just die. So just as one example, because I've looked at it particularly recently, developing ASM. So that really started in the 1980s with Yuri Gurevich, who came up with evolving algebras as his thesis. Then Egon Boger really was probably the person who pushed the community side. So Yuri was very good at the technical side. Egon, also a logician, so good at the technical side, but also good at developing the community side. So that was very important. And probably without Egon, the community wouldn't have developed in the way it has. It's produced models for all sorts of different things, some of them listed there. So it's had its books, and then we had ABZ and so on, developing the conference side and the book side. So there have been a couple of books. I've suggested they need a third book in this decade. So, you know, if you're going to keep the community going, you need to do that. But certainly the ABZ conference is where the community is continuing and thriving quite well. So in the ABZ conference, for instance, now ASM and B are the two major areas, and there's virtually no Z left. So Z, although it's being used in industry in certain areas, there's not much research going on anymore. It's developed now, especially into the B method and event B. So, you know, you need key publications if you're doing research. This is just a few that have come out in ASM. You can see it's continued to this day with key publications appearing every so often. I mean, looking at ASM or abstract state machines mentioned in books, you can see there's a peak. So, you know, they're probably past their peak of certainly research interest. You hope maybe there's some interest in the practice side, but every community has its peak. And like Z, ASM probably has. I think B probably is at its peak at the moment. So. So I've looked at some visualizations. So this is Egon Berger in his ASM. So you can see people who have influenced him and people that he's influenced there. So if you go onto Semantic Scholar, that's got some quite nice ways of visualizing how communities are interacting through papers and so on. So the idea of a community practice has now been more generalized into the idea of a network of practice. So this is really a set of communities of practice that interact. So we've seen with state-based formal methods, the ABZ really has become a network of practice with things like Alloy. I've put the leading people in these different areas with ASM, B method and event B, originated by Jean-Raymond Abrial, TLA by Leslie Lamport, BDM, which again, like Z, is probably not so used now, but it was important development in the formal methods arena, and Z, another important development. So all these form a sort of network of practice because they're all interested in a state-based approach to systems. And then even more generally, the idea of a landscape of practice has been come up with, which is, if you like, a set of networks of practice. So in case of formal methods, you know, there are different approaches. So we've looked at the state-based methods especially, but then there's process calculi with CSP and CCS. That's another set of communities of practice that's really a network of practice because they've got common interests. Algebraic specification, again, a common approach, but different ways to do it with OBJ and so on. Theorem proving, lots of various different theorem provers, you know, all of which can learn from each other. Model checking, which is a very active area now, and is probably one of the major areas for formal methods to be developing at the moment. But again, lots of different model checkers, each of which has their own communities around them, etc. So there's probably others, but I've listed the ones that I know about especially. So in the paper, I talk a little bit about visualization because I'm interested in how you visualize things, and in particular visualizing communities. So I'm just going to show you a few examples of visualizing communities. Here's one with me on Facebook, which you can visualize. So these are all my Facebook friends, but you notice there seem to be a lot of people on one side and a lot of people on the other. So there's me in the middle. And then on this side, well as I'm quite an interdisciplinary person, so I do a lot of stuff with museums and the arts, digital culture and so on, not so related to formal methods, but a lot of my friends and colleagues are in that area, but they don't talk to formal methods people that much. So they all form a little group, or quite a big group over there. But then on this side, there's the formal methods side. So all these are formal methods researchers who happen to have a Facebook page, and I'm friends with them, but very few of them are friends between the two, except for me. So you get this sort of bow tie effect when you have something that ties two communities together. I guess I'm the knot in the middle there. This is another hand visualization, but this was the programming research group in Oxford, and obviously different communities within that and working together. So these are just a few people who've written papers together. There's Jim Woodcock, who's was a Z person, has moved on to other things as well now. There's Bill Roscoe, who's a CSP person. So Jim was also interested in CSP, so writing with him. Bill interested in semantics, so on, writing with Jeff Sanders, who's quite mathematically oriented, so more fundamental papers there. Then Jeff Sanders, well, he's written papers with, well, I've written papers with him. There's Ian Page, who's probably a more practical person, programming research group, coming up with things like hardware compilation, but interested in how you can formalize those as well. And of course, well, everyone's, you notice the person at the bottom left there, I guess he was the real core of Tony Hoare. But also, you may notice, this was a group photo, and you may notice a small baby there, a lady. Well, that was actually my wife and then very young daughter. Now she's grown up and is a chemist, so we've actually written papers together on visualizing molecules and so on. And my wife's in museums, that's why I'm interested in museums with that Facebook view. So we've written papers on that together. So there's Tony Hoare, and there's He Feng, who was also a very central person of the programming research group, now back in China. So looking at, for instance, He Feng's group of co-authors, this is his little community. And I guess amongst that, for instance, you can see all these Oxford authors, but there are other communities in there, you know, from China and so on. So if you visualize how people have done things together, you can get an idea of how these different communities connect together. This is my link, so you can see me in the middle and He Feng just up there. But these were all Procos authors with that project I mentioned earlier. I've been to China quite a lot, so I've got Chinese authors, so you can see them all there. This is a more recent one. If you go to connectedpapers.com, you can visualize all the references in a paper, so that can be quite interesting, especially in a survey paper. So in this case, you know, two of the co-authors, that's Jim Woodcock, I think those are all his, I guess, colleagues who he's referenced in their little network of people who have collaborated together. And this is John Fitzgerald's little network, because he was another co-author. So you can see actually those were quite separate, but they've come together to do a survey paper, and that's good because they can bring together these different communities in formal methods. We're coming to the end. So yes, I'm coming to the end of my career, I guess, because I'm now formally retired, although I'm still active writing papers and so on. And because I've been going for a while, you know, when I started, a lot of the stuff was on paper. Now, of course, much of the stuff that we produce is electronic. But that meant I had a huge amount of archival material still on paper that my wife didn't want me to keep at home. So I had to get rid of it somehow. Unfortunately, John Tucker at Swansea University set up a place where he's archiving formal methods and material. He's got stuff by Linus Bjorner and so on. But anyway, he very kindly accepted some of my material, which actually ended up being 64 boxes, which is 1 million binaries. So I thought that's a good number for a computer science archive. That's the back of my car taking it, so you can get 64 boxes worth in a car, and they've all been moved to Swansea. So anyone who's interested in communities and how they connect, that might be some useful material for doing some more research on looking at Procos. There's all the material on that, on the Z community and so on. So that's sitting there as a archival resource for future research in such things. So I have written a paper myself on it, so that's it there. So anyone who did want to do research on it, that's the place to go, because I at least give you an overview of what's in each of the 64 boxes, but not much on how those are organized. So certainly within the boxes, there needs to be some more organization. So a little summary of the talk. So formal methods are at least open communities in general, so that fits with this workshop. We've looked at communities of practice. I'm very grateful to the reviewers for really making me look at networks of practice and landscape of practice more, because I hadn't really looked at those before. So certainly more research to be done there. And as I said, I'm interested in visualization. So all these communities, it's interesting to see how you can visualize them, because certain patterns can show up once you start visualizing them. So one thing I'd emphasize is you do need a variety of skills to develop a community of practice. So you can't just have technical people, you can't just have researchers, you can't just have practitioners. You need admin people essentially to admin skills. You need teachers to teach what you're doing. You need researchers to develop the knowledge. You need practitioners to use that knowledge. So you need to bring all those together in a real community of practice. I think certainly for formal methods, and probably for many different areas, we're moving from fundamentals. You now need tool support for a formal method to be successful. So if you're developing a community of practice around formal methods or other areas, tool support is very important. That's the paper on this on the website. I'd just like to say thank you to all the progenitors for the various formal methods. I've listed a few of them for actually starting them off. I haven't started any formal methods community off, but I think I've been somewhat instrumental in at least developing those communities. So I'd like to say thank you very much to everyone, and happy to answer questions. Antonio, you're muted. Antonio? Anyone who wants to unmute and ask a question, you're very welcome to go ahead anyway.
Well, sorry, I was muted. Yeah. I continue speaking, I couldn't realize. Terrible. So there is not much time, but please, if you have any questions.
May I? Actually, it's kind of a curiosity, because I don't think I can make sensible questions about formal methods in all the variety of aspects we have been talking about. That was what was intriguing me, was the development of the initial COP. And what I was curious about was whether you have been measuring the participation and comparing the participation of the kernel that you have shown us with respect to the other participants. I mean, how many people that were there, how many were participating heavily, and how many were not participating, and so on. Because one of the big problems of the community of practices is to bring the people together and let them exchange, at least, if not.
Yes. Well, most of my experiences of communities of practice was before I knew there was such a thing as a community of practice. So I wasn't actually sort of measuring things explicitly, although all that formal methods archive material, there are things like delegate lists of all the said meetings and so on. So somebody wanted to do some research on that, there's material there to try and look at how things link together. Nowadays, of course, we've got Google Scholar and so on, so you can look at what papers people were publishing, even if they're old papers, they tend to be online somewhere. So you can look at how things are linked together. Certainly I haven't, there's a lot of other things you could do research in like that. And I guess my main research has been using my brain to remember what happened and try and think about how the community of practice developed with my involvement. Yes, I may publish more things on that if I get round to looking at some of that information. But at the moment, yes, I don't think the formal methods community does much introspection on that sort of thing. And it probably takes a social scientist really to come in and do that properly. I'm a computer scientist, so really we need some social scientists to try and encourage them to come in and do that, perhaps. I mean, there are people who have shown a bit of interest in the formal methods archive, who are more interested in the historical aspects. And I guess that includes how the community developed. So perhaps somebody else will be able to come in and do that. So I'm certainly very happy if anyone's interested in that to sort of help them and guide them in what I know. But maybe I'm not the best person to do it in a sort of independent manner because I was so involved with the community.
Okay.
Any other
questions for Jonathan?
I'm happy to chat in the chat, or I think most of you got my email. I'm jpbowen@gmail.com. I don't write it down much because otherwise I get lots of spam. But hopefully, if you're interested in contacting me, that's my email address. I'm happy to discuss things further.
Okay, then.
So there is a question in the chat.
There is a question in the chat. Okay. So yes, you can read it. Probably is better.
Yeah. Yes. Well, it's about the fact that it's applicable to many fields. Yes. It's a general framework. I've only applied it to formal methods because that's the area I know. But I'd encourage any of you, if you're developing a community yourself, have a look at this framework and see if it will help you in developing it further. Because probably if you're in active development of a community, you're somewhere along those different areas of development. So you can see where you think you are in that, and then think, well, what's the next stage of what we need to do to make the community reach the next stage? Because if you don't do that, then the community will die at one of these stages. If you're successful, it'll get all the way to the end and morph into other communities. But it can disappear at any stage. It can never get going if you don't foster it in a good way. I think Zed, we can claim we did get through to the end stage, and it's fostered things like the bee community and so on. But yes, do think about your own area, which doesn't have to be formal methods, doesn't have to be computer science even. If it has a community involved, you can use it as a framework.
Okay. So, thank you very much, Jonathan. So I think we can move on.
Sorry for overrunning.
It's okay. We are a very informal community.
Good. Yeah.
So
I'm informal too. Yeah.
Okay, so I hand actually the control to Marco, who will share the next two papers.
Yeah. Okay, so if Aidar Shakerimov is ready, he can now present his paper, Acquiring Software Engineering Skills by Contributing Advanced Open Source Projects, which I think is a student experience and description. It could be interesting.
Yeah, thank you. Yes, it's indeed a student experience paper. And it's about my first experience in contributing an advanced open source project and obtaining some software engineering skills from this interaction. So the outline of today's presentation is the description of my motivation for contribution to this project. Then I will describe the project itself, its general aspects, like as being an open source project, its technical aspects. Then I will describe my role in which I contributed this, and also work that I done. And then I will discuss the results of my contribution. So my motivation for contributing this project called Scikit-learn is because I'm a beginner researcher and developer in machine learning. And as usually research communities tend to use shared software tools that are available as open source. I'm interested in exploiting, understanding the tools such as Scikit-learn, a popular machine learning framework that usually is used in studies, in teaching machine learning, and so on. Also, I wanted to obtain some practical skills in building, like organizing, developing such scientific software. And as some minor interests, I had a necessity for coding experience and also experience of communicating with other specialists in my field. So That's why the scikit-learn project appeared for me very satisfying in terms of my interests. So the goal of this project was described to be to provide the research community with the solid state-of-art implementations of predictive analysis techniques, and to be supported and developed by the research community itself. So actually, I suppose myself to belong to the research community that would use these tools, and the fact that I'm trying to support, to develop, to be involved in the development of this project is actually what the original goal of the project is. So that's why I consider myself to be in a very comfortable position during my involvement. This project also had supplementary aims, such as keeping user friendliness in the software, in the usage of the software, and also being friendly not only for the users but also for the contributors. So like the contributors would easily read the code and also be easily involved. So there is a huge comprehensive and very clear documentation provided, and other study materials like how to contribute this project, how to make pull requests, and so on. So the general aspects of this project is that it was created in 2007. So it's a very, it's considerably old, solid project. It was initiated by one person, but from 2010, it became a federal leadership based project, and now it is managed by about 20 core contributors and about 5 triage managers that help to speed up the process of development by notifying or organizing, categorizing the issues, the pull requests, and so on. The project has its own GitHub repository, a mailing list, a website, and also several pages in different social networks. It is BSD license, so it means that it's a non-copyleft. As can be seen from the pulse of the project, it is a very active project. So in the present months, it had more than 100 merged pull requests and more than 73 closed issues. The technical aspects of this project is that it is highly modularized. So it's a uniform API, and each module is independent from each other. So each module can be developed in parallel, independently, and that's very easy for contributors. So you're not, it is not necessary to know other modules to contribute a specific module. Each module are also very similarly based on 4 main classes. Like each module contains estimator, predictor, transformer, and model. So they are, it is easy to navigate among them. Also, there are good documentation. There is this documentation about the stable release and also the version that is currently under development. It was also noticed that there are a lot of unit tests for merging the updates, so it's high quality unit testing. My role during contribution was a code developer. I was focusing on fixing bugs. So I used the following criteria for selecting the issues for being assigned. I wanted to be a lower level of difficulty, and to clearly see the requirements that our issues provide, and also be able to understand it theoretically. What was easy, what was helpful in the process of issue selection is the labels that triage managers put for each issue. So it was seen whether this issue is difficult or easy, or requires some complex analysis and so on. So I selected one module to contribute. There was 3 bugs issues and this module was named Gaussian process. And I considered this to be understandable because I tried to read some theoretical background about this from a book, and it was considered by me to be understandable. So the first issue that I was assigned to was the issue where some configurations made the program to throw an exception where theoretically it should not do that. So I found out that the root of the problem was the division by 0 in some of the vector operations, and that was because when initializing the vector, at some places, since some values were not given, they by default were set to 0, and when the algorithm tried to make a division of vectors, some values were divided by 0. So that was the problem. And but before I came up with the solution, I found out that this issue was solved in parallel with me by another contributor. So he was not participating in any discussion under the threat of this issue. So nobody, including the triage managers and the person who posted this issue, none of them knew about this fact that another contributor has changed, has updated this code, and it was solved. So what I've done for this, what was my contribution, I just notified a triage manager about this fact, and that it is necessary to close this issue since it's already solved. So that's the end of my contribution of this issue, and then I tried to solve some other issues associated with the same module. So there was 2 issues that actually repeated each other. So there was about a functionality that didn't work with some specific configurations, but actually it should have been worked. So I understood that the problem was with the in the process of multiplying some matrices that were exploited in algorithm because they were with unsuitable dimensions. So after reading some theory in the book that I mentioned before, I suppose that reshaping the matrices would solve this problem. But when I created a pull request and also described my solution to the core contributors, it actually was not merged because it did not pass several tests. So although I was my assumption was based on the knowledge from the book, there was no way to verify this correctness because I don't have because I didn't have some other sources of information, and also none of the core contributors were able to answer my questions during the discussion of this pull request. So I guess that there was some gap in theory that didn't allow me to complete this pull request correctly. So as a discussion of the work, I would say that yeah, the 3 issues that were assigned were not actually solved because they were not merged. And as the main problems, I may call the, first of all, absence of deeper theoretical knowledge about the module. So probably selecting such a such professional projects which specializes on such specific and deep theoretical knowledge was a bad choice for a beginner contributor. And also I spent a lot of time on identifying the issue, the solution. Also, I was not able to present my solutions probably in a correct way. Probably my solutions were also I was not able to verify the solution also to myself. I was not sure whether my solutions were correct. Also, another problem was to follow the instructions that were provided by scikit-learn project for contribution. So the files that contain the information about contribution were too long for me. It was difficult to follow them, and also they included a lot of unclear terms. For example, when I did pull requests, it was difficult for me to understand what is, for example, the linting problems, the changelog problems, and so on. So although I learned about them during my pull request, but this took quite a long time. So there were some minor problems. So the code was well documented, like in the separate files, but inside the code there were not so many comments. So probably like other contributors which are more experienced would be able to understand what is happening in the code. But for me, as a beginner, it was a bit difficult to start the involvement before I understand what happens in these lines of code. And also, there was a case when the parallel development of a same issue happened. So I guess also I think that triage managers worked very well, but since there was only 5 or 6 of them, but as we saw from the pulls of this project, actually there are a lot of issues and pull requests happening in a small amount of time. Probably this number is not enough, so such cases happen. But the positive outcomes that I learned from this is that I have seen how triage management is useful for organization and management of open source projects. So they were very responsive. They responded me very fast, and they were also very polite, very friendly towards all contributors. So it's created like a will for me to continue participating and so on. Also, I've seen that the high modularity of this project, that the modules are independent from each other, was a very useful feature of this project. So I was probably, if I need to consider more modules, I would, it would be very difficult for me to get involved. But since each module were independent from each other, I need to know only one theoretical concept. Yeah, and this decreased the complexity of the project. So these are my preferences that I used, and yeah, thank you very much for your attention.
Okay, thank you, Aidar. Are there questions for Aidar? Well, maybe you want to think some more about questions. I have some curiosity to ask you, Aidar, about the number of the issues that you have been taking into considerations while you were trying to select some issues to work on. Did you check many of them, all of them, only some of them? How many of them did you check?
I think I have, at least I have read like what these issues are about. So there was approximately like 10 or more issues that were labeled with the like easy or medium level of difficulty. So, and I have read the issues, the issue threads, but I was focusing on also on the theoretical concepts that lie behind them. So each module is about some algorithm. So and I just decided to focus on that one, which was more or less easier for me to understand. Yeah, probably when I was considering this project, I thought that I have quite a lot of knowledge in machine learning. But when I came to the issues, I found out that there are a lot of issues that are concerned the algorithm, the concept that I am not familiar with, but those modules that are those modules that are related to what I know, there were no so many issues related to them. So yeah, so
okay. And look, what are there questions? Did you develop some questions meanwhile from the audience? Otherwise, I could ask last thing to Aidar. What you made an experience, and so maybe you have some suggestions that you could give to a colleague of yours going to undertake the same task.
yeah.
What
yes.
these suggestions would be?
Yeah. Actually, I have suggestions. So first of all, probably it's not a good idea to start contributing scientific projects if you don't really know the subjects too much. So I was just a bachelor in computer science, so I probably should have considered this. And also I noticed that people actually contribute, like they actually contribute even without like targeted search of the issues that they could contribute, because usually I noticed that there are a lot of issues that were done by non computer scientists, that just people who use this project, and they were finding some bugs in terms of like they were expecting these results, but they obtained this result. So this should be a bug, and they report these bugs and so on. So probably this is how actually mainly this project is contributed, not by like coming and trying to figure out which problem can you solve, but probably just by using it. And if you find out some problem, you can report about it. If you can solve it, you can also solve it, and so on. So yeah, yeah, that's my suggestion.
Yeah, so better to start from the problems that you have.
Yes.
Okay, okay, thank you very much. I think we can directly pass to the next paper. So Olzhas Zhangeldinov should be ready to present his paper, which is entitled Learning from Mistakes in Open Source Software Course. And this is another student experience, so we'll say something similar with different nuances, I hope. Please, Olzhas.
Hello. Good afternoon, I guess, for most of you. It's evening here. So today I want to talk about the learning from mistakes in open source software course that I took. I am Olzhas Zhangeldinov from Nazarbayev University. I am a senior computer science student currently, and I took the course last year. And I want to talk about my experience in this course, about my mistakes that I did when I tried to contribute to projects, and what lessons did I learn from these mistakes, and how new students can avoid making these mistakes. So shortly, the outline of my presentation. Firstly, I will talk about the background in open source software that I had before taking this course. Then I will talk about the course itself, how it was outlined, the stages of the project, like the actual project selection and assessment methods that were used to grade the students' performance. Then I will talk about the project I selected for this course. I will not dive deep into the technical aspects, but I will give as much as required to understand what maybe I did and what mistakes I did according to this project. And then I will talk about the mistakes and lessons learned from these mistakes when I tried to commit to this project, when I interacted with community, and when I made some self-reflection at the end of this course. And then I will give overall conclusion. So I will start with my background. I had some background in open source software before taking this course. I did not commit to the open source software. I was not a contributor, but I used it very much. I loved the open source packages because I wrote web applications on PHP, and I used a lot of packages from Composer that is used like packages in Packagist. So because I used them, since I used them, I went a lot on the GitHub pages of these packages. I read about the issues, about the bugs currently present in the version. I tried to avoid these bugs, maybe as a passive user, and I read some change notes on the projects that I was interested in to see the new features and what can I expect when I upgrade to new version. So mainly I was a passive user of open source software. And about the course itself, it is an open source software course in Nazarbayev University. It basically consisted of two main parts. It is theoretical and practical parts. The theoretical part covered some management information about open source software projects. It was about license, governance, business models, some about roles and as a contributors. For practical part, we needed to it consisted of several stages. So firstly, we needed to select a project and a role. Then we needed to contribute to this project. We needed to write weekly reports about the work done to this project, about our contributions and our interaction with the community. And then we needed to write the final report. It was basically the reflection over all the work we did and all the mistakes we made. And at the end, this paper I submitted is the kind of evolved from the final report I made for this course. So first we did project selection. Firstly, we needed to pick a role. I picked the developer role because as many other students, because everyone wants to commit to new features, to write a good code, and basically apply their skills, the software engineering skills during the course. So I think the selection process was a very important part of the course because picking a wrong project could lead to many problems that student can experience during this course, during the contribution process and during the writing these reports. Because since we needed to make our work weekly, it was important to have the weekly work, because if we didn't have our weekly work, we could not write the weekly reports, and we might fail the course, or at least not succeeded it. So the selection process consisted of 2 stages. Firstly, we needed to pick 5 projects. We were given 1 week to find 5 good projects on the GitHub. Mostly searched for projects on the GitHub because it's the most large repository. And then after a week of studying these projects and trying to identify which project is the best for this course and which might give the potential to show, we needed to make a final choice. So we needed to choose one final project that we were going to contribute at the later weeks. So it was important to make an equal study of each project because the final choice is very important, and the thorough research should be done to find any flaws or any advantages of each project. I think I did not do a really good job on this, and I will go in order. So what I will skip the first part of selecting 5 projects, and I will just go to selecting the final project, because the first stage was only finding projects that I was interested on the search bar in GitHub. So in this table, I showed some metrics that we were given about the projects that could identify whether this project is good for the course or whether it is bad. So I picked the 5 projects: Laravel, Nextcloud, Grafana, Zola, and Nushell. I will not give a thorough description of each one because it will be a long story to tell. So I will just show some numbers, and as you can see, I highlighted these numbers in colors to see to let you know what was concerned most about in these projects and what I thought was an advantage of the project. So I ordered them in such a way that the higher the project, the most familiar I am with it. So the Laravel, I was the most familiar with it, and the new shell, I was completely new, almost completely new to the stack and to the project. So as you can see, that higher projects are very mature, they're quite old, and they have a lot of commits, a lot of features to learn. And I think that this was kind of disadvantage, because a lot of features to learn meant a lot of time spent on the learning itself and not to contributing. However, they have a very good frequency of closed pull requests, so it would be much easier to keep the weekly work and to have our pull requests like closed almost instantly. On the other hand, the lower projects, they were quite new, and the features could be very major to contribute. But the work went really slow there. So it was like 1 closed pull request or 3 closed pull requests per week. I thought this could be a problem for me as a student of a course, because I needed to make I needed to make sure that I make my weekly work. So I chose the Laravel project. I was the most familiar with it. It is a back framework written on PHP. It was mainly inspired by Ruby on Rails. It is quite old project. It's almost over than 8 years old. It is large and complex. It has a lot of features. So contributing to it, I needed to like learn a lot about the project structure. But I already knew some project structure because I already used this framework. And I tried to learn it before taking the course. So shortly about the project, the governance structure is a benevolent dictator. No, the maintainer is Taylor Rothwell, and he decides on every feature that is merged or rejected to the framework. Also, the Laravel framework is a group of developers that are most active in the project. So this is about this UML is about like the project structure and its technical aspects, but it's quite not really clear right now. I will go back to it when I will be explaining what I did to this project. So for the first commit, I made a small feature for routing. It was like a feature that I always wanted to see in my projects using Laravel. It was really small, and it added like a small method decreasing the amount of boilerplate code that I had. It was mainly inspired also by Ruby on Rails because they have such a feature, and I wanted to like adapt it to Laravel, but it was not accepted by the maintainer because as I knew, as I found out, it was in a soft freeze mode. Unfortunately, new major features, and maybe not relevant or not important features were rejected at that time. So I could not commit my feature to the project. So my mistakes by now were that I did not notice this soft freeze mode. I should have like watched carefully to this project and find that the new features were not accepted. Also, that I wrote a too long pull request. It was really long and included too much details and examples, despite it being very like a small feature and like 5 or 6 lines of code changed. So I think that also it also misled the maintainer and other developers about the amount of work I did. So the project was in a soft freeze mode, and I couldn't I couldn't contribute my new features as a developer to the project. So I decided to switch my role to tester and find new bugs and report them. Firstly, I wanted to find any known bugs and try to fix them, but the issues tab was almost empty because a lot of the bugs were already solved by that time. And every bug that was emerging, a lot of developers were focused on fixing these bugs because they did not make any new features, but they fixed bugs because of software mode. So I found that it was not a lot of work for me to do because I usually make my work very slowly, and the issues are solved almost instantly, within 30 minutes or 1 hour. So I found I tried to find some bugs. There was not a lot of bugs because the project is very mature, but I found some small bug. I will not. I think I don't have a lot of time right now, so I will not tell all details of this bug. But I will say that I proposed my own solution and it didn't work. As some contributor pointed out, he fixed this error and showed me the almost working code as I thought. So I copied it to my local instance of the project. I tested his solution. It was the right solution. So I waited for him to close this to make his own pull request and merge his code, but he did not make it within 1 day, I think. And I made my own pull request where I wrote that this code was written by this contributor. So for the third week, I also tried to find bugs, but I could not find any during the several days. So I thought that I could find some if I scan for the last added features on the pull requests tab. So my thoughts were that some new features could make some bugs, and I could maybe point them out and try to fix them. What I found is I could not find any bug in the last features, but before when finding for bugs, I noticed that there was a new feature option missing for root registrar and old feature for resource, and there was also an old feature for resource or registrar. I can show it right now on this UML. So there is a module routing, and there are two registrar classes that allow to build like root logics, routing methods in an easy way. So the root registrar registers routes every single route, but resource registrar it registers a group of routes for a group of REST routes for a given resource. And there was a missing there was an option named missing for the route registrar, which identified the fallback function if if the model could not be found for this route. But there was no such a option for resource route registrar, and I thought it was not intentional. I thought it would be a good contribution to add this missing option to the resource route registrar, because intuitively it should be there, because the missing option can also be bound to the resources. So it was not a mistake. The feature was merged by the maintainer later, and I think this was my success, because I think I found a work to do, and I found a feature that was merged. So as for the lessons learned and for conclusion of this presentation, I can give like some advices for new students that I think would be very useful if they take this course. So as for the project selection, I think the better attention to the last commits should be given during the project selection. So if the student tries to select some project, they better like watch. They better open some recently closed commits and see with what messages they were closed. And if this message kind of resembles that the project is in a freeze mode, it would be a bad sign for the project, because the project in the freeze mode is really hard to contribute as a developer. So if they take this, if the student takes this, it would be hard to succeed as a developer in this course. So regarding interaction with the community, I think my lessons learned was that the pull requests length should not confuse other developers. And if the changes on this pull request were minimal, the pull request should be very short. And regarding the keeping up with the course and keeping the weekly reports written, so it's basically means that you should find the work every week and to not stop working. So if it's hard to find the task on the current role, it's better to switch role. So if you are a developer and the project is in soft release mode, you should switch to tester and test the features currently present, because as a developer you will not be as useful as a tester. And also it would be useful to scan for the last added features and see how they work with old features, and if they introduce some bugs in the project. And that's it. Thank you for your attention.
Thank you. Olzhas, and the audience has some questions. Actually, in your conclusion, I was a bit confused, because basically you started as a developer and then changed to a tester. But the first recommendation you do is for the developer, basically, and you have to select your project very carefully and check if it is in the freeze mode, in the soft freeze mode, because you want to develop something, right? So basically, there are two tracks in your experience. One dedicated to the developer, and the other one to the tester, I would say.
Yes, I was actually very indecisive, I think, about what I want to do during this course. But after I picked this project, I think after I made my selection, I think I was committed. I decided to commit to the Laravel anyways. So I decided to like give up my idea to be a developer, but rather be useful for the project itself. So
would you have chosen Laravel the same if you were a tester from the beginning?
No. I think if I noticed the soft trees, I think I would not choose that. Yeah, I think it's it may contradict with itself, but I think it was this point where I make my final decision to choose Laravel, and before I could change this decision, but after I made it, I felt like it would be like a shame for me to choose another project.
Okay, yeah, well, you see, life is full of contradictions.
Hmm.
So, as the audience, an additional question, otherwise we are done with this session. Okay. So I think we can stop here and have our break and then come back for the keynote of